Hi and welcome to Advanced Technology Solutions LLC Lighting Division LED video, I guess one of many. This video is going to go into LED optics for aquarium and horticulture, and as well as spectrum, what makes them good, what their positive negatives are, and basically why we're not selling them from a inside manufacturing standpoint to a reselling or wholesaling another brands. Just to give you an idea of the light that's coming in, you can tell, we're going to get into the purple here in a second, but you can tell that there's no real off light, no shadow light coming in from outside. That's light from here going out. It's just a Philips 100-watt Xtanium driver. We're actually using 25 watts of power today in this video. As you can see from ambient, all of our tests that we show publicly are done basically on a budget box philosophy, or whatever you want to call it. To give you an idea how we do our testing, our initial testing is similar to this, done on a budget with just parts scavenged around, just to give ourselves a baseline of, is it worth going in deeper and whatnot, and then from that as well, then we take it to advanced stage where we actually spend quite a bit of time and resources in getting everything in the proper spec format, and then going out and doing our experiment. And then once we get the results from that, then we go back to the budget philosophy of, can we do what we did in the professional high-end world and mimic that in the consumer world. To give you a baseline, if you haven't already guessed it, we're not out to profiteer from our customers. We're not out to sell products to our customers that we personally won't use after thorough testing and whatnot. So we have to make sure that everything can actually be done. And also from that consumer's perspective, not every consumer has $1 million to drop on something that may or may not work. So even if it works for a lot of people, it may not work for one person. So there's cost in that, and then it's overall lifetime cost versus efficiency. So to go back to this video, we have a 5-foot candle. We're just using a simple hydrofarm light meter, so that way everyone has. We're at about 5-foot candles because we're on the far left, so we don't have to use any multiplier as a ambient light. This part of the video, what I'm gonna go into is just base optics of LEDs. This is actually, and I'll go into this more fixture in a bit, but we're back down to our third step of our testing. Can we replicate our results from using high-end optics and whatnot in an entry-level way, I guess. I'm not sure how you'd explain it, and to be honest, we're not the greatest at videos, but everyone has to have this information. Put the line here so that way you can see, let me go off, that through both part of the videos I'm going to be going down the same line, so that way we'll get the same reading. We're about center, and like I said again, we're back at the budget test of, can this actually be replicated without spending a lot of money and using a lot of professional engineering aspects. So we're going to do our first test of just the LED array we actually use cardboard, and I'll go into how it's reflective on the inside, but right now there's no real, let me show you real quick, there's no real reflection going on the inside, on the long sides. On the short sides there is, and I'll go into that here in a bit, but that goes back to the budget. So under no real reflection on either side of the LED, and this is actually about 3 inches or so of light that would actually just be coming out here, because with an LED they emit generally at a 180-degree pattern, so we would have light loss here, which is just hitting the wall and not doing anything for your plants. So this would actually be better than what you would get without anything on the sidewalls, because as much as they're just cardboard, they are acting as somewhat of a reflection. So we're going to go through here, and you can see that we do get up to 106, 108, and 11. I think we get up to 111. Maybe not. Oh, let me get back on here. And you can tell that there's basic reflection coming from the cardboard, that this point is brighter because this is where 100% of the light is coming from the LEDs themselves, and then some from the sidewalls, and then this light over here is a little bit from the LEDs that's caught on some of them, and then a little bit on the sidewall as well. So I'm going to do this one more time so you can see. And we tip out at 109. We've taken our two side walls out that were covering up the reflective part of the walls that were in here, and you can see that as we go up through here, and also before I go any further, you can see that this is actually widened, and you can see that it's got hotter points here and here, as you'll see by a spike, the minor dip, and a spike again, and that's because the reflectors are compensating for the light that would have been lost. And this is, I'll go into this here in a little bit as to why you need the reflectors. I just want to prove it first and then explain it. And see, we've already exceeded before. See how we had a high point, we're going to drop down again, and then we're going to have a high point again. And the reason why we have the high point is we're actually getting reflection. The reflectors are actually giving us light that would have been lost back down. And when you go in, and the reason why I'm showing this is that when you go and you look at a lot of these LED fixtures out there, they're just a PC board panel with LEDs on them, and they're all flat, and there's no real optics going on. So you have quite a bit of light lost. Within that, you don't really want to be looking at LEDs. They're actually bad for your eyes, worse than anything else, minus something that has UV or anything. Excuse me, because you have a really bright blue and a really bright red peeking at you. So let's go back here and just show you one more time so we have proof in the pudding. And yeah, our videos are long sometimes, but in the long run you'll get the and this reflector design in this box was just thrown together again on the budget side to ensure that these results that we saw in the professional environment could be replicated in a consumer environment built with cardboard, some silver tape, and LEDs and whatnot. Now, I will say not everyone can go and build an LED array easily. We actually do LEDs professionally for the commercial world and some other niche markets that are out there. We just haven't brought them into the horticulture world for the reasons that we've already gone into and that I'm going to go into deeper. We've delved in it a little bit in the aquarium world because it's shown some positive results, but in the long term, it was not being feasible. So let's actually go and show you this LED array and how the reflectors that even our budget built make a huge difference. You can actually see there's an LED there, an LED there, an LED there, and an LED there, and you know, so on. Those aren't actual LEDs. Those are the reflection from the LED there. So let's flip this over, and you can see what I was talking about, how it's silver. And let's go back to brown, which, as you can see, it's still reflecting, and as you can see, it's not opaque and sucking up all the light, whereas it would be like as if it's going off to a wall. So this cardboard's actually giving you some reflection. You can see the difference from this to this. So you need actually, in any LED array, no matter how big it is, you actually need reflectors. Another reason why we're not going into some of our other, we could do a budget style reflector of some of the ones that we've tested and developed ourselves, but they're proprietary in their IP right now, and we're going to use those on our LED array that we do finally bring out when we feel it's right, not before. We're not just about to make, sell something just to make money. We want to actually have something that works and that we can stand behind. And going, I just want to make sure everyone can see there. And what is actually comprises this is 6 blue, royal blue, with a actual color binding, but they're close to a royal blue, 3 red, and 6 royal blue in a specific color bin that we chose, 6 red in a specific color bin we chose, and 3 white in a color bin we chose. And actually the white is added, and we might, anyway, the white is added because in LED, as you'll see, a lot of LED arrays out there are just red and blue. And as we learned with high pressure sodium, and this is going into the horticulture side, but it's great that we're covering horticulture, commercial, aquarium, and consumer, so that way they all carry into each other, and you can take one thing you took from one to another. But going back to it, most LED fixtures that you see out there are red and blue. And going back to HPS and metal halide, same concept. Metal halide's got very spiky blue, unless you get a full spectrum metal halide, i.e. the Hortilux blue or Ayahuasca Sierra Arc red, or some others out there that are full spectrum, but then you have lumen maintenance issues and and they're predominantly blue. But going back to that, with HPS or metal halide, and then when you combine them, and metal halide's got big green in it, so that's not the greatest comparison to the blue, but it is. But we all learned that we needed full spectrum. We needed orange, we needed green, and as much as plants don't and whatnot don't really use it, they do use it for triggering mechanisms, and they do use it a little bit. You needed infrared, which is not found in LED at all, and which is not in this LED array. In our test, we actually add an I'm not going to go into too much detail on that, but we do add an infrared heat source that gets turned on at low level during the light cycle, and then right before it gets turned off, it actually goes up for a little bit to promote flower stimulating, which is what promotes it in nature as part of it, besides timed light and whatnot. So you need full spectrum, and that's one thing we saw, like with the chameleon grow system. It combined LED with plasma. And we'll go into that in a whole nother video, but plasma, in our opinion, is a great tool in some commercial aspects. We don't, and now mind you, we've been dealing with plasma lighting for the past 4.5–5 years. So if it was a great technology, then we would have brought it to the horticulture world then. Plasma lighting does show some promise more in the aquarium world and the commercial world, once you get past initial cost, longevity, other whatnots. As much as it's saving energy, there's a lot of other costs that can quickly become a higher cost than what you had to begin with. But going back into that, plasma light, no matter whether it's sulfur plasma or metal halide plasma or ceramic metal halide plasma, which is actually where we see it going. We're not going into that at all, but with plasma, it's predominantly blue and green and yellow, and the red tapers off. You might get a few spikes here and there, and then they add, the LEDs to compensate for it. So that gives you a baseline of that, and I hope my videos will make sense in the long run. I do them all without a script. I don't have the time to write a script for these, to be honest, with our R&D work, the company, and supplying our customers and talking to them and all that good information. So anyway, you can see, I just want to make sure everyone can see how these LEDs are. And as you see the way that the pattern is, this is a optimal pattern. This isn't the pattern that we would go with exactly, but it's very close to the pattern that we would go with when we actually bring out arrays. And there's a way arrays have to be built besides optics, but you have a blue, and like, let's say, just for an example, if your plant was right here at the center, the top would be getting a lot of the white, and then from any angle it would make sure that it would always be getting a different spectrum, and nothing would be caught in shadows, because that's the other problem that you face with LEDs. If you use optics, either reflection or refraction, you run into the problem of you can cast shadows if your LED array is not a big enough footprint. I.e., if you have something the size of a dinner plate emitting 500 watts worth of LED power, that should mathematically equate to about 1,000 watts of HID light source, and give or take. That's just a very general idea of how LEDs work. You generally can get away with half the power if everything is done right. But if you had that 500 watts in the size of a dinner plate, you're not going to cover any footprint. You have the inverse square law of light hitting you, which really detriments in LEDs, and then you're going to have shadows, and you're going to have, you know, extreme shadows. If you took that same 500 watts and put it in a 2.5 foot by 2.5 foot array and had that, you would have less shadows, but you can run into other problems of how you're going to place your LEDs, different efficiencies go into that. Just to give you a baseline of one of our LED array concepts, that if we were to actually bring one out, and I'll go into why we're not bringing it out in a second, but if we were to actually bring one out, there would be 3 times the LEDs of what actual the power output of the device is. So let's say if we brought out a 300 watt LED array, it would actually have 900 watts of total output power, but we would cycle the LEDs at different points in the array, so that way you get your full power. It still wouldn't upset your plants. You'd still get the optimal out of the plants, and you'd gain the efficiency out of it, out of the entire reflector, and also the heat management that comes into it. If you go and watch one of our other videos, we let the LED get up to manufacturer spec with the laser thermometer, right at manufacturer spec, and put an ice cube on it. It was actually sizzling, surprisingly enough, and you could see the foot candle output actually increased, even though the meter had got bumped more off center, so it got a loss in light instantly. Even with that, during the cool down process, you saw the foot candle reading skyrocket up. So LEDs, even 1-2 degrees, will decrease output with, you know, any amount of heat that is generated. This is 25 watts worth of LEDs. These LEDs are actually underpowered, but they're only being driven at 25 watts in total power. I'm not going to go into the detail of how much power to each one, because we have competitors out there that would just run with some of our information and think they have it and do more harm than they can do for the customer. And going back to that, if we find an LED fixture that we actually think has great potential and you know, is very close to coming out and being, you know, something that's already on the market, you know, and something that we, you know, think that just with some minor modifications can be, you know, top dog, we'll contact that company and you know, try to help them as much as we can at no cost or low cost, for the benefit of the consumer. I.e., if we don't think what we're going to bring out is going to be out in time, you know, and they have something that's close, we can help them, and then maybe, you know, not even have to bring out ours, because they're going to bring some, you know, modify theirs to an acceptable level, you know, something like that. So we're not out for our sole interest when we are secretive about our products. We're secretive about our products, one, so people don't just run with stuff and mistake information and whatnot. But as you can tell, this is made of, you know, with, you know, cardboard reflectors, a fan here to keep it cool, and even with this fan and the 25 watts, this heat sinking is, it far exceeds manufacturer specifications for these LEDs. However, this can get warm. So, and we've run this for, I think, in this exact design, it's been almost 1,000 hours, I want to say. Not in this specific one that I just built here, but in the first budget one. The reason why we don't have that one anymore is I dropped it on concrete. And as you can tell, there is no protection. The other one didn't have the cardboard on it yet either. Permanently attached, it was just on there with tape. So when it fell, it went dead. And that's just one of the, caught myself in the fan. But again, we do, you know, all of our testing from it starts off as grab what we have, let's see what we can, you know, come up with it, you know, at first, and then go into the professional environment and actually spend some resources of the companies to actually get a realistic device built and a operation tested, and then we go back to, can we actually build this on a budget to see if you know, every consumer can do it, because there's a lot of consumers like me in my personal life. I like to build things and honestly just will get put on a shelf as soon as I'm done building it, just because I want to build stuff. So there's a lot of customers that want to build stuff, and there's no point in us saying, oh, you can do this if you have a CNC router at your house, or a couple lathes at at your house, or a mill for cutting glass. Just not everyone's going to have that, so we have to make sure that everything that we come out with it can actually be used in every aspect. So what we're actually going to do with this next step is put it in a 1 foot by 1 foot by 3 foot grow tent with a tomato plant that you'll see some pictures of, that we let clone in there under a red, blue, and white, and let it stretch out a little bit through light manipulation, and allow the roots to gain a good structure. And we snip the top off, and it's in there for the past 2 days. So tonight this will be in there. Our next step of the reason why we actually designed this reflector here the way this was for the test, one was to show you what we just showed you, but also this is going to go in there spinning. I have to add the mounting brackets, and that will be part of another video to explain how you can get 25 watt to actually give you some kind of results. Because to be honest, no matter how we design this array in a square circular pattern, it would not do 1 by 1 in a way that we would want, because you would actually have shadow effects. So if we go and put it on a spinner, which to be honest, from a LED aspect of 25 watts, a spinner is fine. And going back to the reason why we're using a spinner on this, it's easier for us to build a spinner than build the LED array in a smaller format of what we have already in our testing. And that goes back to what I said earlier, that if we built a 300 watt LED fixture, it would actually be 900 watts total outputable power, but it would only drive 300 watts at a time, and do it in different segments, so that way you wouldn't have total shadowing, and you get your total watt output, and your plants would be happy. So in this, we're just going to spin it because we can make a spinner easy and have it last. But once you start getting any weight on a spinner, you start losing electrical conductivity between the brush and however you're going to actually move the power from one end to the other. And that's the one of the negatives of some of the spinners that we've seen out in the horticulture world. We like the concept, however, there's a longevity period and other issues that can come into play. So I do appreciate you watching this video. I hope some of it made a little bit of sense. After you see some of the other videos, you'll probably understand a lot more about what we're saying. For now, you might be like wondering what we're actually going into. But just going back to this LED, just remember that all this light that would be coming off here and every other fixture would just be going off and hitting your wall. It's basically unusable for your plant. So you need optics on your reflectors. Generally, just having an LED on a PC board inside it, behind a plane of glass is not, it's going to look cool, and it's going to give you results for veg growth. But when you start getting into flowering, some of the heavier, dutier plants like a tomato or a pepper, something that really wants a lot of light, wants that thermal energy, wants that full spectrum, you're going to come into problems. While LEDs are fun for everything else, when you get into something that's going to be a heavy producer, they don't have it. And I'll be honest, I mean, we can make, this is going to sound kind of funny, but we would make a lot more money if we were to start selling LED rays in the horticulture world, especially the ones we've designed and can build through our sources over the ceramic metal halide. However, watt for watt, dollar for dollar, we cannot beat ceramic metal halide from the Philips 4000 Kelvin HPS retroweight. And even within that, we keep trying Sun Pulse. We try GE ceramic. We try Sylvania, ceramic. We've tried other brands of ceramic, and it ultimately comes back to the Philips right now. And within that, soon you're going to see higher efficiency ceramic metal halides with the same spectrum of the Philips 4000 Kelvin that we're seeing in the horticulture world. So instead of looking for a 600 watt ceramic metal halide, you're going to be looking for a 300 watt or 280 watt ceramic metal halide that's going to be putting out essentially like 500 watts worth of current power. So that's where we really see it. And then for dollar, if you have a power surge on an LED array, or if one LED goes out, you have an entire series of LEDs going out. Unless they drive every LED individually, and that is, to be honest, super expensive, because each LED would have to be individually driven, so it would require its own circuit on the circuit board to do that. So when one fails from a power surge, or just because the LED decided to die, you're out an entire part of your array, and then within that, getting it fixed, you're going to have to send it off to somebody. The total, out cost, as far as electricity efficiency, they're very efficient, but you have to think of long-term cost. How is it, going to go into it? If you get a little bit of dust on one LED, or one starts dimming, it's the entire array's SOL. LED array is going to set you back $300 to I think a Chameleon system's a couple $1,000, and some of the other ones that are out there. A realistic one that we've, some of the ones that we've seen out there, that if we were to if we had a customer that said, "Oh, I need this, I just want to have one plant, and I'm whatever." There's one current one we have that we've seen out there, and we've actually gone out and purchased it and tested it. We don't say it's the greatest, and it won't work for tomatoes or peppers, but with that said, it will do a good job of some other low-lying plants. But even that has a reflector design in it, so it just comes back to do you want to spend a lot of money and then have the risk of having to spend that money again, or do you want to spend a little bit of money on ceramic and have long-term good results, and if you have a problem, you can just spend a little bit of money and you're back up and again, and worst case scenario, you can go get an HPS from Home Depot for 20 bucks and you can be up and running again that day. With an LED, if you go down, you're down for the count. And going back to power surges, if you have an LED array and you must buy one, you have to buy a uninterruptible power supply for it. I cannot stress that enough. As much as people think, oh, they're only for computers, you have to remember your LED driver is like a computer power supply. It takes your power coming in, no matter what the voltage is, as long as it's within regulation, which is house power. It takes, no matter what the voltage or current coming in, and outputs a set voltage and current, like the LED Philips Xtanium driver. It is a constant output. Its output is 4.1 amps DC. Its voltage out is 24 volts DC, no matter what the input is. So it can actually, when you have a what's called a brownout, besides surges, that's an instant killer, but brownouts, when you have a brownout, all this is stressing to make sure that the output is the correct output. So if you don't, and when you don't have enough, it will kill itself and deplete itself to make that output. So you need an uninterruptible power supply. And if you questioning it even further, if you've ever seen your lights dim in your house when your air conditioner or microwave comes on, or anytime, if you've seen it because another light comes on, you got a real problem, or when you plug in your vacuum cleaner, that's a brownout. So everything that's electronic is actually stressing. If you have any electronic device, I would actually recommend having an uninterruptible power supply. But on an LED system for your horticulture, because your plants cannot take a 2-day stint without light. They need light, to survive. Anyway, thanks for watching our videos, and I hope this made some sense. I will start trying to do a video overlay before I do the video, so that way I can have like a nice, somewhat nice presentation. But if you know our company, you know that we do everything on the fly for our customers, and we to make sure that we can do everything and maintain everything, some things have to be overlooked, and that is like writing a script or something. And to be honest, I wouldn't follow it anyway. I would get a thought in my head and have to delve onto that. So know again that if we actually thought LEDs had a place in the horticulture world, we'd already have it. If you have a aquarium fixture and you just need some supplemental lighting, we can help you with that, but stress that you stick with HID. At the end of this video, I'll put up some pictures showing what this looked like when we first cloned it, and how we let it grow out, and then how we snipped it back. And as you can tell, there is a little leaf that's about, he's already out. But anyway, this is what the clone chamber was for this LED video. The next part of the video will be posted in the next couple weeks, because obviously we have to give the 25 watt array some time to make the little plant grow. But it will show you that eventually the 25-watt array, and we'll move it into a bigger chamber, will actually, even though it's 25 watts, it should be equivalent of like a 50 or 75 watt HPS or ceramic metal halide, they would say, but you'll quickly see that it will overgrow itself. So you can see there's a red, a blue, and a white. This LED array was just thrown together, literally just thrown together to do this test video, because people were saying, well, you know, LEDs are great and they work great. They do in very specific applications. Also with this, you can even see that there's red and blue shadow effect, and that's coming just from there. So you'd have to have an enormous array to not get shadow effect with LEDs. And people say, oh, I don't see the shadows. Well, you don't, and that's one thing that this is demonstrating by just having one set of them. This is allowing it to where the contrast is that much bigger, so you can actually see the shadow effect. And this is not going into some of the base LEDs that you see out there, because they don't have any white, which is a necessity. If your LED does not have any white in it, I wouldn't even consider it no matter what, even if you had no shadows, because that goes back to why we all went from HPS and metal halide to ceramic and iHorticulture blue, is because we realized that plants needed full spectrum to actually thrive. And that's one thing that Philips ceramic metal halide actually overcame against the iHorticulture blue, is that iHorticulture blue is dominant in blue. It was a metal halide probe start ballast lamp, and it only had a 65% lumen maintenance and a 12,000 hour life. The Philips ceramic metal halide HPS retro white has a predominantly red spectrum, so it's better for flowering. It has a 15,000 hour life and has an 85% lumen maintenance. Now this video is not going to try to sell people on the Philips ceramic. This just is trying to go over to spectrum and why in the HID world why we went to full spectrum, and this will carry over in LED. And eventually we will be either bringing out ourselves an LED fixture, or we will be teaming up with somebody else to bring out one that we feel is actually good. However, right now LEDs just don't have the power without the right optic. If you don't have the right optic with your LED, you need a lot more power than what you think. It's just, there's a lot of misconceptions in LEDs right now, and that goes into anything from LED, home fixtures, commercial. You have to set it up right for your environment and get something that works for your environment and make sure everything matches. And if you make it match, you can make some things work to an extent. To give you a little back idea, Philips Europe sells LED for very light cloning and like lettuce type plants. If companies like Philips see it in a value in that but don't go any further, one is because they don't, you know, there's obviously money behind everything, but within that, their own researchers, I can't speak for what they're thinking internally, but they would have brought something a little bit bigger to life if they thought they could. As you can tell, they're in the horticulture world with some of their HPS lamps, so if there was something real there, they'd be there. Some people say, well, NASA uses it. Well, if you're going up in space and you can't carry any extra light bulbs, yeah, you want to use LED, but you're not also going up there and growing tomatoes and peppers up there. You're growing very low light, you know, needing plants. So anyway, thanks for watching our videos, and come back and see how this little guy is doing. We'll be posting photo updates on this guy on our photo album page, so you can watch the photo updates in the meantime, and then when the video comes out, we'll post that video showing how big he gets under the 25-watt LED array, and shows some of the benefits and some of the drawbacks of it. That's the other thing, is it's not just how your plant looks is the other problem that people forget about. If you really want to know how your plant is doing, I suggest grabbing a refractometer, and when you grab that, that will actually tell you a lot more about your plant's health, because you can actually have a plant that doesn't look very good, but its sugar content is excellent and it's actually thriving. And that's, you know, that's a rarity to have one that doesn't look perfect, that is perfect, but that just gives you an idea that looks aren't everything. You actually have to go in a little bit deeper and check it out. So thanks again. Be safe, guys. this part of the video is going to be the last, but this shows you how much of a small footprint to get an optimal footprint you would get out of this. As you can see from the reflectors, you get the hot point. Again, this is just a baseline to give you an idea. But when we go down and actually get it to where the two ends overlap, and you can actually see the hot line, which is where the overlap is. You can see how it's shadow there, and then it becomes hot there. That means that is the optimal, where you're getting the optimal placement front to back, side to side, and that gives you about a 5-inch spread on the one side, and then about 2 inches bigger than the fixture. So in reality you get a 10, because you're at 10.75, you get about 10% more than what your array is in footprint when you mount it optimally, just like in this example. But you can see that there's shadow, and then as we come down you can see that you don't have a shadow anymore. So basically, to the plants in the middle here, they're getting light not only from directly above but from both sides, so they don't have any shadow effect. Here you would have a shadow, and this actually would be the optimal point if you had your plants in the center, because it would just give them a perfect bath on both sides, plus the light straight down. But again, and as you can see, there's nothing has been changed about this since you saw it just a minute ago. So reflection, reflector or refraction in a setup LED or anything else is key about it. But as you can see, we go from having a shadow to a hot point, so that you can tell you would have that's how you would do your mounting or whatever. But that just gives you an extra side tip about it. But anyways, thanks for watching this 30-some minute video, and we greatly appreciate it. Hope you learned something. If you want, please give us some comments back at sales@advancedtechlighting.com or info@advancedtechlighting.com, and just reference the video you saw and what you thought we should change about it, or anything like that. Thanks, be safe, bye-bye.